Hi guys, my name is Bob Grinier and I'm a volunteer with the Martin Fleischmann Memorial Project. Okay, so I think it was Jason, I think he guessed it right. I didn't want to do another presentation tonight, but Peter, who's a long-time follower of the MFMP, he decided to get out the ultrasonic cleaner that he had and give a hand at this type of ultra experiment. And what he did was share his first video, and it's everything I would have liked. What I've seen over several years is something that looked like Magneto hydrodynamics, and a presentation I gave at the Russian conference really focused down on that and specified that precisely. However, I wanted to see things in hydrodynamics as an analog, regardless of the fact of whether it does transmutation or not. I believed that the same thing would occur in both places. And I think today, yes, today I received a video around about just before lunchtime, and I think it has most of the detail in there. So when I said on Sunday night, I think it was it Sunday or Monday? I don't know. But anyway, I said there is a hell of a lot of low-hanging fruit that people can get by trying this ultra type of experiment. And I think he's got some of the low-hanging fruit. Yes, it's a case of a little bit more time resolution, getting the beginning and end frames exposure like such that you can link the two together. You'll see the same kind of problem we had in some of the earlier Vega experiments. And also some more spatial resolution is necessary, but only to just put icing on the cake. But essentially what you're going to see tonight, I'm going to bring in several things that I wanted to share for quite some time, because I think it's okay to have in your mind how something's working, you know, and for me that was by the end of 2018. I had a good idea at the beginning of 2017, but by the end of 2018, having been to Suhas Ralkar, videoed the sprites, seen the structures on the SEM from his material, the strange radiation, and then the strange radiation in mid-September on the sample from the first Lion reactor that I got a chance to look at, and so forth, and all of the features on Lion 1, Lion 2, and so forth. They made a pattern, and I saw this pattern repeating from that point onwards, and so it led me down this Magneto hydrodynamic thinking. Obviously Shoulders was there, and we know that is also something that he would consider. And I really think today I can show you some video that will essentially I say, you know, it's different because my daughter's just had her 6th birthday, my younger daughter, and so I can't say I like to be able to explain it so my 5-year-old could understand it. But I believe that with this video, like the video yesterday, I would hope almost anyone can understand that this is just like an apple falling off a tree, and that's what it is. And you will see this in every single over unity system that exists, because we don't have multiple universes. I know it's a discussion point, but we're in this universe, and we're working with what this universe can do. And so people might think something else is going on, but they have to account for at least what I'm going to show you tonight. Anyway, so who we got in the room before I... can people hear me first off? Am I okay voice-wise? Let's check that before I go into this. So hi Corky, hi Jason, hi Agadi, hi NTP. Yes, I looked at the design. The problem with any design like this, go back to what Shoulders said, I think in an MIT conference, I think it was in 2006. He says, like any type of device that you want to create, thinking you're going to create excess heat out of this technology, it's going to destroy the reactor. And so you have to have a design that bears that in mind, that it's going to destroy the reactor. And so the idea of controlled burn, I really go back to Tesla's original open-ended steam evacuated vacuum tube with the feeding tungsten wire or the feeding mercury, and creating the exotic vacuum objects that he called electrical particles of matter at that time. Of course, you know, that's the name he gave them. You feed the beast the fuel rather than have the fuel there and send the beast to the fuel. In the case of radiation remediation, you can do it either way because you're not really interested in keeping it. You just want to transmute it. So, but anyway, it's good thinking. Axial designs with tips to work on, like columnar sections. But thank you for that. Okay. So Slobodan, I think you're going to see some things here which you might find interesting. It's a small slice of the information that's available, but I think you're going to find that interesting. Okay, sound is good. Excellent. This is good. Excellent. Fantastic. Perfect. All right. Okay. So I don't know who has seen the Monopole Clutch presentation, but that is a key presentation. If you have not seen that, then you're going to be a little bit at a disadvantage because I'm not going to go completely over it. But it is quite important to see that. So the presentation I gave as my contribution to the Russian Cold Nuclear Transmutation and Ball Lightning Conference, I think it was number 26, last September the 30th. 2020, and I brought together a number of concepts from Ode with both material I had up and to the point of that, and then subsequent to that, and I think some of the things that I discussed at ICCF 22. One key feature that I said I would come back to. I'm going to touch a little bit more on that, but it deserves its own presentation. But like I say, when I see the material that I'm happy with, that I believe will convince anyone, I have no choice but to get it out the door as absolutely fast as possible. Otherwise, I'm not going to be able to sleep. So that is where we are. Okay. Okay, right. So I'm going to go to that presentation. So let me get my keynote up here, and we'll go to it. And I'll skip the first sort of number of slides, but I'll go through them quickly because of needing to give the context to it. Okay. Okay. So, guess I do play, and it'll go onto the other screen. Hopefully, you'll see it up there. Are you seeing it? So I think you will be. So I'm going to get rid of my face here, okay? So you should just have the presentation there in a second. Okay, so this is the Monopole Clutch. This is the presentation that I gave, and I talked about the fact that this could be 12,000-year-old libation disc from Egypt. I think it's in the Metropolitan Museum. It has the shape on the top, which is actually often not as symmetrically round as this, and then it has the Ankh shape at the bottom, and that the angle on these is variable in various symbology of the Ankh, but the actual geometry completely lines up with the slice through the kind of mark that these structures leave on an X-ray. And this is actually the movement of electrons over the film and photons, and that's exposing the X-ray. And I just thought it was interesting the way that the way that this fades away is kind of the same way that the depth of the water from the spout of the libation disc changes. And essentially, I've got a source there, but from the ring down. It's supposedly the key to all hidden knowledge, and I think this is the case. There are actually two of these. You might call them the yin and the yang. You might call them north and south, but I'll talk a little bit more about that as we go through. Okay, so I'll skip this. This is Oroitskev. So he had his exploding foils in a chamber, and the chamber above the chamber, he had a mirror, so he could look at top down on what was going on at the top of the chamber, and you can see with the camera directly pointing at it. And he was creating these ball lightnings in some of the discharges outside of the explosion chamber, and so he's taking a photo from two angles, effectively looking at this. And 0.7 meter away, here in two 90-degree places away from this ball, or the actual explosion chamber, he had pieces of iron 57 foil, and then on the back of one he had a north pole of a normal magnet, and on the other one he had a south pole. And what he found was it changed the magnetic field structure of the iron 57, which is a very good nuclear magnetic resonant isotope. And that meant that he was able to collect on the iron, or close to the nucleus somehow, by having a magnet, one or other pole, the opposite pole of a magnetic charge. And that would be, therefore, a magnetic monopole. So he's saying magnetic charges here, and he talks about it there. And there's a discussion here which is not necessarily supported by the author now, but it's saying that then this was in 1983, that if you could, in theory, create a magnetic monopole, you could take protons and then make them decay and produce vast amounts of energy, and it would continue to do that. So that's an article there, and I had this video, and I talked about when I did this experiment I don't know if you can hear that, but it's not so relevant, it's going and this is in the Nova reactor. When I did this experiment and looked at the ash that came out of it, the magnetic ash that came out of the iron spheres that were produced, so you can see there's two areas here. The one which you're pointing at now, that is the magnetic sample. And so we put that on the SEM, and when I looked at it under the SEM, some very key features popped out. So she's going to look at that. Let me go to that. And essentially, if we go through, I don't know if you can see it, maybe I've got it on the next slide. But there are these spots here, and if I go to the next slide, I think I've got an animation here. Have I? Here, maybe. No? Have I got an animation? No. Oh, yes, I have. Yes, I have. Sorry. Okay. So basically, the magnesium, the aluminium. So one of the spots on the big sphere and the little sphere, that there's like a lump and a hole, and this is the first time that I saw this. You can probably see it better on this slide. So you can see the carbon sphere in the bottom. This is interesting. I can't actually use my mouse when it's in presentation mode. That's annoying. Maybe I can do a switch there. Sorry about this. Okay, well, on the slide, on the left-hand frame, you can see there is a red ball in the eye of like a Pac-Man's head, the sphere, the iron sphere. It's actually like a bit of magnetite that's being produced. And so, and on the one above, it's kind of almost the opposite way round. And if I go forward, it might do this animation. Is it going to do the animation? Maybe here. Okay, so my point being is that this was the first time that I saw on multiple pieces in a SEM a kind of north-south structure, and I sat on that because it was the first time I saw it. I shared the images and stuff, but I didn't at that point in I think mid 2017 push forward the significance of what I thought I was seeing. Anyway, let's step forward. So then one author thinks that it's the Loschak monopole, and this is De Vaux and the group at Fondation de Broglie in France that I showed you the replication of Reutzke. But they're saying that there's some sort of is it possible that such monopoles have not only electromagnetic but weak interactions? Is it possible to produce monopoles in weak reactions instead of neutrinos? And it's saying that finally this leads us to the hypothesis that these monopoles could play a role in the magnetic activity of the sun, in particularly sunspots. And I've talked about this at the top, but they're saying that therefore this monopole may be considered as a magnetically excited neutrino. Okay, so I talked about this. I won't go into this. I'm going to step forward. You can go and look at this on my Sochi presentation. I won't go into this because this is not my focus here, or this. This, I think, we can consider is this mushroom shape, this magnetic charges, but it potentially is riding along the waves that we were discussing in the previous presentation. Okay, so here is the structure, and perhaps I can show this in a different way. I don't know. Anyway, I need to give a little bit more detail on this, so let me do it like this. I will go up here. Can everyone see what I'm showing here? That's the important thing, I guess. You've all gone silent. What's happened? Is that a good thing? You're silent for a reason. Can you see what I'm showing here? Very quiet. Oh dear. Have I lost data? Yes. What does that mean, artifact? Can you hear me? No one's talking, which is sometimes a good thing. Okay. Okay. All right. So what I did was to create the object on the right. Okay. Is I took a Bogdanovich, one of these structures. This is the Perovskikov one where he was looking at a. Okay, great. So he had some 0.4 Tesla magnets, some neodymium magnets at a water kind of petri dish or whatever, and then he exposed it to sunlight, and then he fired a laser, and these things were emitted and captured on standard sort of 400 ASA film or something like that, 100 ASA black and white film, something like that. And they are very similar to the ones that Bogdanovich observed. Bogdanovich created his by using a synchrotron and producing high-speed electrons, firing those into a conversion target, say something like tungsten, producing gamma rays, and the gamma rays, he said, were stripping these structures off the magnets that they then went through, and they're exposed on X-rays. And also Shishkin produced them from a cavitator. So what are these? Well, these are 50% slices through a structure, and actually in Perovskite, I called it a mushroom because I'm mad about mushrooms, but anyway, it wasn't until I got to the Perovskikov paper that he actually called it a mushroom. So in one of my magnetic signatures of strange radiation, I actually had a big picture of a lovely mushroom that I picked and ate some time ago as the title slide. So I consider these mushrooms, and so what I did was in my 3D software I produced a 3D model, and what I have at the center here is a torus, and I believe it's a torus that is creating this mushroom structure. Okay, so what you have is you have a flow either in or out of the electrons. Maybe they're in both cases, but they're spinning in one direction for the north and spinning in the other direction for south. So I have this spin structure on here. Now, if you look at my basic 3-level torus strange radiation structure that I derived from the Hudson Fracture sample impact craters, the actual thing doesn't spin, in my view. It's the individual things spin that we're in them, but it's not. It's all about magnetic structure. The whole thing is magnetic, and it just interacts with matter and causes the matter to spin, and so you end up with it spinning. And if you go to the work of Bogdanovich, he refers to a virtual Dirac monopole, and that this is the shape of that virtual Dirac monopole. And by that it's not a real monopole, like it's monopole in every direction. It's monopolar in that it pulls stuff in and then it shifts it out at the side. So it's kind of rectifying the direction. If you can see on where I've got my mouse here, so the stuff comes in here and goes that way, and I guess on the north it spins in one way, and in the other one it spins in the other way, or spins out. So you can think of it like that. I'm not so convinced it's going in or out, but if you look at the rest of the data in this presentation, I think it is going in or out, or they're upside down. But anyway, you'll see. And it is because of data in the Lion experiment, which I maybe can get to. I need to go here. How do I go forward? Okay, maybe I'll use this. Okay, so it was the Lion experiment, which is one of these. If I show you here, the line experiment has, and I can switch to this camera, it has these cores, and then it has this fused quartz here. And the detail that I'm going to be showing you all happened on this fused quartz. Now this should normally melt at about 1700 degrees centigrade. And I'm going to show you structures that were on the inside of this fused quartz and also structures were on the outside of this fused quartz. And this is all very important to what you're going to see in the ultra experiment later. Okay, so what you're seeing on the slide here are rings that have a hole in them, which are unaffected, and areas between them that are unaffected, and circles that are not quite so clear, if I actually show you the presentation. So what you're seeing on this slide, let's start again, is circular structures that have a hole of unaffected material in the middle and a bit in the middle which is also unaffected. And then you have other ones which are not so clear, but they're there, and they have a very dense thing in the center, okay? And I'm saying that one of these is the north and one of these is the south. So I represented it like this, and you can see here that these two here are south, and all of the other ones effectively are north, or vice versa, you know. And essentially what I'm saying is the material is being thrown into the middle here, or the damage is being created mostly in the middle by something that's going into the middle. And in this case, something is being pulled out, and because it's swept around the mushroom, the exotic vacuum object, it has to be it doesn't touch the bit in the center, so you get that bit unaffected. Now why did I put these circles at the size they are in this structure which I've just showed you? Well, it was exactly because this is the field of influence, okay, in 2 dimensions. So I rotated that and gave the field of influence in 3 dimensions. It actually spreads out, and you can see that it branches out. It's not quite so mushroom. There's a little bit that goes up and down, and you can see this in the structure on the Lion reactor. If I zoom in, you can see here in this particular material, it goes up and down, and this is just material that's kind of just been affected by it. And you can see the spin on it because it's cutting into here and it's pushing this out. Anyway, and then this is the bit of the sort of maximum damage. You've got another one down here, and this is actually the image rotated on my remote view.icu thing. So you can see like almost like a black hole in the center there, where the material's completely removed, and this birdie, as the Russians call them. Okay, so let's come back out on this. Okay, so when I'm playing this through, what I'm saying is that because these are all the same pole, and they're all effectively spinning the material in the same direction, that the space between them, there's interference, and so it's like the calm in an area between, you know, they're kind of cancelling each other's ability to damage the quartz out, okay? And the combined outside here causes it to move more particles around the outside to the end here. And in fact, at the top on this one, I've got my mouse on here, you've got it coming around the top and bouncing and coming round. So I've drawn the angles on there. Now, in some cases, I've got some very close-up images, and you can see them here. And so either north's on the left or south, or either south or north on the right. But anyway, I've done some animation on that, so you can see these are of 2 different sizes. And so the ring in the center has to be this size. I had no choice. And why is that? It's because I deduced from the fractal same but different. It's like in the Hutchison sample, the Hutchison fracture sample, we saw tori both north and south, and I will actually show you that image later at the smallest level. And so there was north and south, and then the diameter of that was then rotated 90 degrees and made a torus by linking them into a chain, into a closed loop. And then that structure, there was another torus of a larger scale where they were linked into a tight structure. And you can see in that video where the damage on the inside is narrow, where the field shape is squished, and on the outside it's wider. And so this gave me at every tier of self-similarity a D4D radius. And what do I mean by that? I mean that this, if I can stop it at the right time, this diameter here is 1, and from here 1, 2, 3, 4. Okay, and I derived this from Hutchison's fracture sample, and then it came about that I was looking at the 1957, I think it was, paper, some in the 1950s of Winston Bostick, who was charged by the US government to convert the H-bomb into domestic fusion, that he saw strike marks from his early plasmoid research that had this D4D ratio. And so I had no choice but to make the center part the same size as the inner part of this circle. Okay, so bear that in mind. At the time I was going, oh, is it really that small compared to the field? Is it really that small? And I've got the other one over here. So this is the other pole, and you've actually got one that's kicked in at a slight angle. Okay, so it's kind of either throwing out or pulling material in. Probably throwing it out because there's nothing in the middle there. Okay, and again, it's sweeping it around. You can actually see how it's sweeping the material around, and then it sprays it off and spreads it out at the end there. And we actually saw these exact same structures like this on an X-ray from a lion core put into a metal T-tin with the self-developing X-rays. I might have one around to show you, but anyway, you can go and look at that. And so it was emitting structures that then would create these same patterns on an X-ray later down the line. Oh, you're not seeing the image. I'm sorry. Thank you. Oh dear. I will get this right. So what I'm saying is, if I go in, sorry. I should have some little birdie in my ear, is that this here is D, and that's D, and that's D, and that's D. So that's D4D, and that's exactly what Winston Bostick showed in his paper, okay, from the 1950s. But I derived this from the strike marks at 3 or 4 quantas of scale, both north and south structures at the smallest quanta, on the Hutchinson fracture sample. And so it was no surprise when I found the same finding in the structure in the work of Winston Bostick on his early work on plasmoids. And so I then had to make, I had no choice but to make the white circular section in the middle of here, and the white circular section in the middle of here, the inner dimension. That's 2D. That's 2D. Okay? And so the tori could only extend 1D outside this center part, which is not affected. Sorry, which is highly affected. And in this case, it could only extend to the area that's unaffected. So here, this is the other pole. Okay? So I'm only able to make it. And so I was grappling for a long time with, should it be this small compared to the field structure? And I decided that is what the nature is telling me. So that is what it is. And so this is the overall structure that I ended up coming up with. Okay, and then I'm saying that these are groups, but then I'm saying that they can cluster together into super structures, which are Magneto hydrodynamic structures. And bearing in mind that this is actually on the inside quartz. So when I was showing you the reactor here, okay, something has been born in the core. Now, the core is diamonds on nickel and saturated after being baked to degas it for a long period of time below the oxidation temperature of nickel with deuterium in a rapid quenching process. So there's the deuterium bosons we talked about in our last presentation. There is nickel to do the dissociation of those. And there is diamond. Diamond has the highest Debye temperature. It's the stiffest material in the universe that we generally got access to. And it is the material, particularly when it's crummy diamonds, that is the best electron emitter. And I actually proposed this in sometime in I think even as early as early 2013. And Lion was the first guy that took up the mantle to do an experiment with industrial abrasives. And so you have this perfect combination of things that was able to create coherent matter, in my view, EVOs in the core, and that some of these became neutral, and they came from inside the core, through the ceramic, through the copper winding. Some of them, and a large number of them, got caught in the copper winding, and I will do a whole video about how that happens, in my view. And then they aggregated on the inside of the fused quartz, and that is what you are seeing here. You are seeing the influence on the fused quartz. Okay, now bearing in mind that this reactor never exceeded the melting point of copper. So this is 1050 degrees, I think was the peak, and this shouldn't melt until 1700 degrees. But it can have recrystallization, okay? And the point is you've got completely unaffected areas, like in the center of this structure and on the outside, and then highly affected areas like this edge here is where I believe you're having the edge of the mushroom is touching here, and I will show further evidence for that. But then you have this structure, which is extremely intense. It's physically quite large relative to the other structures I've just shown you, and if you look at the inside, it's the right hand one, which is the left hand one on the right hand picture. The left hand one is behind. You can see it's behind, and the left hand one is in front. And so if you rotate that round in your head, this one on the right is now in front. So this one here is in front over here, and this one here, which is behind, it's behind. And it's very, very important and relevant, the fact of the distance between these, because this tells you it's a magneto-hydrodynamic structure that has eaten through this. And I haven't had a chance to analyze this for transmutation, but you have beautiful self-similarity in this structure if you go in, and it tends to have this, look, it's a spiral that goes round and comes in, and it goes round and comes in. It's like a yin-yang on the top. I don't know if you can see that. So you've got a little bulb on the top. You're going to see this today. Okay, so you've got this little bulb and then your structure on this. So this is, in my view, a pair, but it could be a pair of pairs of pairs of pairs of pairs. It's a massively self-similar structure. And you've got on other layers of this, you have the same thing. And I've shared this at high resolution in different types of lighting. And also on the back here, you can see this hexagonal structure. This will become important also. You've got the sweep, which is more circular, but there's a very clear hexagonal structure here. And to accentuate that, there is 3 fracture points that are exactly at 120 degrees from the center point of this magneto-hydrodynamic structure. Okay, so the next one I'm going to show you is a massive structure. This I think is 12 millimeters across, and I think it's even bigger, you know, on the field area that's affected on the outside. But this is actually on the outside of the quartz. The reactor was up here, so this has come out of the reactor. It's gone through the quartz, and it got locked into place by the bend on the solenoid, which is the heater coil. Okay. The interesting thing is both of these are in line with the center of the B field. In the solenoid. So you have a solenoid heater coil in here. This one is halfway up the quartz and horizontally in line with it. And this one is in the center line, but it's opposite to gravity. So this is like almost like it's opposing gravity. It's as far as it could get and still be attached to the quartz. And it built up. And if you actually look at this thing, if you zoom in, it's actually made up of substructures which are essentially the same thing. So it's self-similar in its own structure. And so that was fascinating in its own right. And I kind of think of this as like a dual sort of weather system. Now, bearing in mind, you can have these on their own. We have one in this structure essentially on its own. They might be linked, but I don't think they are. So you can have them on their own, but they tend to be in pairs. But these are the same pole, so it's not so important that they are 2 poles when they're stuck in place and growing like they are on here. But in this case, they are, in my view, North and South Pole, and this is North and South Pole. And we found a very specific material on this point, which was, when I opened this up, and you can see the video of me opening this live for the first time, you can see the discovery of this feature in there. And you can see that this was placed in the center of this Magneto hydrodynamic structure with this feature on the top. And that in it, this is the feature under scanning electron microscope. Here it is, and it has these crystals, and the crystals, if you look at them, they are like almost pure crystals, but they are made predominantly of tri-alpha and quad alpha, that being carbon and oxygen, and these are kind of like the end of the normal solar synthesis chain. There is aluminium in there because there's aluminium in the Cantal wire. There's calcium in there, which is interesting because there's calcium nowhere. Chromium and iron are all in the Cantal wire, and silicon comes from the quartz. Okay, so calcium is dec alpha, oxygen is quad alpha, and carbon is tri-alpha. Now, obviously, there's oxygen in the air and there's carbon in the reactor, and we know that these EVOs were consuming the carbon in the reactor. So anyway, that's that. So what I'm saying that we're seeing here is this structure, okay? And over on the left here, I've got a 1950s BBC video, I think it is, or something, where you have a water with some dust particles and a light on it, and they've got an aileron from a sort of model from a plane, and they show in the video the interfering things in the hydrodynamic structure. So you have the center points, so like you have the center point here and the spin on this, and you have the center point here spinning in the opposite direction, and then you have the center point here, and so the full radius goes to the center point of the center point here, and the full radius here goes to the center point over here, and this is exactly what you see on this structure, and it is exactly what you see on the structure on the outside of the reactor. This very white area is this center bit, which meets in the center between the two focal points, and so forth. So I am saying that what you have are these structures that interface with the material, with the material that they're interacting with, and the actual toroid goes 50% into the surface, okay? The toroid goes 50% into the surface. The field actually pokes a little bit through and leaves a ridge slightly above it, okay? But it cuts into the material, and sometimes the north and south poles combine together and shift material, as it did in this, from this side over to this side and onto here, as it did in this from this side over to here, and this is a carbon sphere. So it was very weird to see the same structure on multiple things in this reactor, and then go through, and it almost didn't matter which Lena system I was looking at, I would see these paired structures forming and linking together. But they don't necessarily need to be paired, they can be on their own, okay? The magnetic charges can be on their own. And so this is Aritskev, and I talked about the fact that he talks about how the magnetic charges caused Chernobyl, and he talks about the paramagnetic bound states, and this is what's important with oxygen, and I will talk about that at another time in great detail. I talk about elements you might want to choose for this, and so erbium is a very good one because I think it's paramagnetic, and it has one, I think it's the second highest after holmium, I think it's holmium, or that has the magnetic volume susceptibility. So all of these properties are available on the MFMP's Lena reaction calculator. So then I talk about a Mars gas here. You can go and see my summaries here. You can talk about the virtual magnetic monopole here that's been synthesized, and that is essentially the same shape as that calculated in theory as a Dirac monopole, Bose-Einstein condensate at Aalto University. And this is, I think, a paper in Nature even. But anyway, there we go. So we're seeing it there. So I wanted to show... I mentioned this before. This is the snowballs on cobblestones, and you've got the yin and the yang here when it burnt a hole through the 10 yen coin. And then what we're looking at here is a structure over here where it was converting oxygen into sulfur. That's fusing those together. So here is our structure, and this is the substructure within that. So you can see it's a torus made of tori, okay. And so they that each one of them is kind of got a weak one pole and a strong other pole. And then that still allows them to magnetically link together, and then that creates a structure that, because it's spinning in one direction, will then create a magnetic pole of a similar structure at the next fractal level, and then they will join in this level, and then that then creates a structure that's bigger. And so you can see how these self-similarly scale, and this is all based off the data on the Hutchison sample. Okay, so you then put this into a surface, as I showed you before. Okay, so this is 50% into the surface. Okay, and this is the bit that protrudes out through the surface. Then we look at the 10 yen Amasa gas, and this is the optical microscopy, and you've got scallops out of here from a larger quanta structure that caused this material. So we're looking at this area over here on one of the yin-yang sides of the overall macro exotic vacuum object that interacted with it. And then you have this structure here, and it's actually eaten out the material and got this. Now, what a 10 yen coin is 95% copper, 95% copper, and 3 to 4% zinc, and then it has potentially up to 2% tin. Now, you need to bear this in mind when we start talking about what happened to this. When we start talking about this, remember what I'm telling you in this particular piece of this presentation, okay? Because copper is paramagnetic and zinc is diamagnetic. Now, if you actually look at the scanning electron microscopy, so as I showed you here, this structure derived from the X-rays and derived from the field pattern damage on this, and this, gives me this structure, which goes into a surface like this, leaving a little bit prone, and this is what you see in reality, okay? And so I'm going to now press play, and you will see the kind of me throwing this thing in, and then it producing, this is copper, a copper ring around here. All of the copper's been eaten in this dome, and just got a little bit, and this is literally prone of the surface. And by the way, there's a higher level of concentration of carbon in this ring as well. And then it has this film of zinc. So the zinc doesn't appear to have been eaten, and it's diamagnetic. Whereas the paramagnetic copper is at least being shifted. So I'm suggesting that there is very, very intense magnetic fields. Even if it's not eating it, it is causing it to be mobile in a way that it's not doing with the zinc. Okay. So I explained the PAP engine. I'm going to do the PAP engine in a lot more detail. I explain the accident and why you can go and have a look at that. I talk about Yule-Brown remediation and how that works and so forth using Brown's gas, and the actual specific choice of elements and why he did it, and I talk about the mild steel and so forth. You can go and look about how that worked there, and this is the first time that this image was disclosed, and hopefully we can do the replication of this later in the year and so forth. I talked about this structure. I think that's where I want to go with that. So then I came into the Solin patents, which I found in August last year. And in the Solin patents, he talks about creating a self-sustaining chain reaction. There's a nucleation of magnetically charged particles in the metal melt. Magnetic charges that automatically arise and are maintained in its volume lead to the decay of protons and are the catalysts of nuclear reactions. So if you decay protons, you're going to produce mesons. They're going to cause all kinds of nuclear reactions. Magnetically contaminated particles are generated and accumulate with the generation of superconducting currents. Electromagnetic, nuclear and gravitational forces are combined, that's the unification of the forces, with the formation of coherent radiation. Coherent radiation. You may have heard that term used before. The first time I thought about coherent radiation is when we were with Piantelli in 2015, and he said when he was starting his nickel hydrogen reactor up, he had a borosilicate electrode pass through where he was down and he was fiddling with some knobs, and when he started the reactor up, something came out of the reactor and it produced a nasty burn on his shoulder. So he believes that he something came out of the reactor that was extremely intense light of some type. So coherent radiation. This is in 1992, and you can go and look at this in your own time. And then it says, due to the implementation of coherent ultra-fast explosive crystallization, which we replicated using Amasa gas in Japan, it consists of many fragments and dispersed areas in the form of ordered clusters of microcrystals, which are separated from each other by voids. And then he has several images in his presentation. His patent. Sorry, you can't see what I'm showing you here. Sorry, again. But in his patent, so I was referring to, you can go and look at these again. These are the things I was saying. Nucleation of magnetically charged particles, magnetic charges that automatically arise lead to the decay of protons. Magnetically contaminated particles are generated and accumulate with the generation of superconducting currents. Electromagnetic, nuclear, and gravitational forces are combined with the formation of coherent radiation. And he's talking about magnetic solitons. Magnetic solitons. It's nothing's new on heaven and earth. You just have to pay attention, really. So he says here, protrusions and depressions. Protrusions and depressions. Bear that in mind when I'm going to show you what I'm going to show you. Periodically occurring on its surface correspond to the maxima and minima of the intensity of spontaneously generated alternating magnetic field and characterize the appearance of magnetic solitons of two different polarities in the resulting magnetic superconducting liquid. Due to the implementation of coherent ultrafast explosive crystallization, it consists of many fragments. So he's saying that when you have the product produced, you get these beautiful crystals that are due to a coherent nuclear process. And so he had this image in the October application for his 1992 patent that was awarded and is now available for anyone to use. And I'm drawing your attention specifically to these structures up here. These are Magneto hydrodynamic structures, which he drew in there, and he's got other structures in there that Shoulders saw, that we saw on the Lion reactor, that we saw on the Lion reactor in multiple places, which are exactly represented in his device patent. And so here's the Magneto hydrodynamic structures, and I've got them here. And he also has the first sketch of strange radiation, and then actually in his 2001 patent he shows the SEM that he used as a basis for drawing this. So this is from 1992, and I've just got one that I've got from the Amasa vibrator plate there. So just to finish off this before I go into the main part of today's new information, I just wanted to show this explosion from the Amasa gas experiment. Okay, so that was it, that little explosive event. And you can see it there. You can go and have a look at this, and you can go and see what we're going to look at is this area, this kind of browny area here, and these are the coherently made, instantaneously made crystals. Okay, and on those crystals we had conjugate nuclei, helium nuclei, i.e. alpha particle conjugate nuclei coming from titanium. And this is exactly what he's describing. Crystals with voids. Okay? Alright, so are there any questions at this juncture? Let me see. Okay. The strange radiation isn't between the black and the white EVOs. The black and the white EVOs are two states of EVO. You have a north and a south magnetic charge, and these form the pairs, and so on. Bring on the new stuff. All right, Axel, okay. All right, so it is with pleasure that I present to you, and I just need to get it up. Let me find it for you. Oh, it might be on this memory jobby WhatsApp. Give me a second. Talk amongst yourselves. Okay. Mm-hmm. Okay, that's typical, isn't it? Doing it. So let's go, yeah. Okay. So I think this is a very high frame rate video that he slowed down to 230 frames a second. And it's a standard kind of ultrasonic cleaning tank with a CD case top and foil over it in the Allan Kusk glass bottom boat approach. And I've got this so that I can see it. Let me show you here. I'm going to change that to frames, and we're going to switch this over. Okay, and I'll put that in there. Okay, this should do what I want. Oh, that's the wrong one. Idiot. Sorry. Aha. Okay, I can do it like this. Sorry. It's coming. Okay, all right, we're good to go. Oh no, I need to bring in the audio so you can hear something useful. And be able to control the audio so it's not too loud. This is worth the wait, by the way. This really is worth the wait. So go and get a drink. I'll give you like half a minute. This is worth the wait. I want to do this. Yep. Okay, that's too loud. Can people hear what's going on in the background there? Can you hear that? Well, I believe these things produce wormholes, so that's one thing. You can't, in my view, travel backwards in time, but you can travel forwards in time with this. But that's a whole other discussion. Okay, is that everything on frame? It's not quite everything. Okay, this will do for you. Okay, let me just check. Okay, right. Okay, let's see. Right, is everyone ready? Are you ready? Right, I'm going to play it through straight away as usual and see what you can see. You ready? Okay. The foil again, yes, but this is a replication of the foil. And I'll just play it once through more again. I'll get my notes for the order that I want to walk through this with you. Okay. John is saying, would the effect still work if the foil was sandwiched between two layers of some clear plastic material? That's effectively what was being done with the work of Tom Claytor in replicating the work of Roger Stringham. So, yes. And I don't know why I can't get my notes here. Okay, so... So the first thing that was actually noticed by Allan Kusk today when this video was shared on remoteview.icu are these structures moving around. And you might have seen something similar to this before in our presentation earlier today. But what I'm referring to, if I can zoom in up here, if I can actually find it, where is it? There you go. It might not be super duper clear, but you have a classic magneto-hydrodynamic interaction here, and it does have a little bit of the look of a hexagon around it, but certainly you have this overlapping, and in my view that fairly closely resembles what you are seeing when you are looking at these kind of overlaying structures here. You see that? See that? And if I go over here, these structures here, so like that. Okay, so absolutely confirmed in my view that this is happening. Now, this is hydrodynamic here, and this is no water at all. There's no water here, and there's no water here, okay? Something came out of the reactor and influenced these materials, okay? And they did this. But this is a very beautiful analog of what is going on there. Yeah, it seems to be dual structures, and I'm going to show you something that is so breathtaking, and it only needs to be put into a higher resolution, but it's predictable that it would have been there, and it was just beautiful to see it today, because it just makes my life a lot easier to explain what's going on. Anyway. So this is the first structure, and actually if we zoom out and we'll step through it, you'll see a number of these. Now this might actually be as big as it is because it might be closer to the camera and it's out of focus because he had a small depth of field on this, and that's why it's at higher resolution than we saw on Allan Kusk's work. So Peter he's got some microscope that he might try to use. I may try to do some with high frame rate and high fidelity as well. So I think we're going to go very, very quickly from here. And I do know that already 5 or 6 people have bought ultrasonic tanks. So like I say, it is really open season for who can get the best data in this. And you can already see when I show you imperfections in this data set that someone might be able to do better. But I'm going to step through this. And what I'm going to show you is, for me, the real money shot. And just because there's a slight bit of movement here, I actually stabilized it. But what I'm referring to is this central part of the frame here. Okay, this is very early on, and this is absolutely mind-blowing. What I'm about to show you here is it's just going to be like you see the light. It's going to be, this is how it is. That's how it is. Okay, so let's do it. Okay, so I need to just switch. I need to switch sequences so that I have the bit that I've stabilized. Okay, and I want to zoom in, but I'll do that with you in view. Okay, so we're going to look at this area around here. Okay, and this is very, very early on. So the trick is with this is you can probably find most of what you need to see very, very early on in the process. So I'm going to zoom in. So we're at 75% here. I'm going to zoom in. It's 200. I think this is where we need to be at 200. I think maybe 200 will do it, or 400 will do. I think we'll do it 200, and then maybe if we can go 400. Right. Look at what happens here. Out of this already yin yang, it's a hole and a lump. Have I got the right place? No, I haven't got the right place. Have I got the right place? Or maybe it's too far back. Let me just check I've got the right place. I don't know whether I've got the right place. Give me a sec. This is a problem with being too much zoomed in. Okay. Okay, I know what I'm doing now. This really is worth the wait. Yeah. 150. Okay. Get that in the center. Thank you, Peter. I've had lots of conversations with you over the last many years, and it's just great that you were able to contribute this into this process. Okay, I think we can do it here. Maybe that's a bit too big. Okay, we'll go here. Okay, all right, ready. So you're looking at the center of the frame here, okay? And I will step forward and something will come out of this hole. Now this isn't penetrated, this aluminium, it's just indented. But what you'll see is something comes out, and here it is. It's this black splodge you see here, okay? Can everyone see that before I move on? Can everyone see that? This little black spot in the middle here. Can you see it? Can you see it? No? Okay. All right. Well, the interaction's quite slow today. Okay, John, you can see it. Good, excellent. Okay, you can see it. All right, so here it is in the center frame. Now, if I step forward, it slightly goes at an angle, and you can see a little bit of white through it. Now, there may be a shadow down here, or it might be another one. Is it a shadow or another one? Well, I don't know. This is at this angle, and the shadow is at another angle. This is at this angle, the shadow is at another angle. Is it because of where the light is? I don't know. But what happens is these come together, the shadow and it comes together, and you get a black circle and a ring with a white bit in the middle. Black circle and a ring with a white bit in the middle. It almost looks... There is definitely one soliton here. There's definitely one soliton. This is why you need more resolution. Definitely a one soliton. Is this a shadow that comes together, or is it a soliton of the opposite polarity? And when they merge, it rotates almost immediately to be parallel to the surface of the aluminium. And then step forward, step forward, step forward, boom! Go back, go forward, boom! Now it could be just one soliton, and it's just hitting. So if you, I'm going to switch to frames down the bottom left. So down the bottom left, you can see the frames. So I'm starting on. It's made it's synthesized, say, on 223, 224, 225. You see here, and then there's another one that looks like it's over here. Is this a shadow? I don't know. But whatever it is, that this has formed, and it's now taking all of the light out of the room. This is definitely taking all of the light out of the room. And it changes that angle, almost looks like they merge, moves over, boom! And the damage, the dent, is far, far larger than the structure. There is a vast amount of energy stored in either this one soliton or two that merge into this hydrodynamic pair. Boom. Okay, did you see that? Something's happening that this is not able to let the light through. I'll go in closer, maybe this is clearer. So it basically comes out of nowhere. There's this, and then it looks like there's something over here, and then they come together. You have a black side and a white ring with a black ring with a dot in it, and then it goes over here, and then boom, makes this very large crater here. So, you know, there's a blue ocean of opportunity here to find out whether it's only one soliton that's needed to do this incredible damage and being this size, or whether it's two solitons that come together and form this black with the ring below, and then it does the damage. Boom. So is it one soliton or two solitons? Well, from what I showed you earlier in the other sequence, one might think that it is two coming together. So where we were looking at up here, if I you see these structures going around, and they seem to go around in pairs. You can see that there's this pair traveling around here, and we go into that. So I don't think that this is, you know, one and its shadow below. I think this is two as a large, either a large soliton or a large two large ones, or they're out of focus. You're seeing the same kind of thing but closer to the camera, but the depth of field is low. But in this case, what we are seeing here is absolutely certainly one soliton, but possibly two, forming a yin-yang pair at this point that then drift over, and then boom, they do the influence there. It could be a shadow, yes. It could be a shadow, and this is where there's still a blue ocean of opportunity for people to get involved. Okay? Now, I'm then, what's my next note? Okay. So I will go to the next section in this video, which is at the end, assuming I haven't messed up things. Okay. And I'm going to look at this area over here. Now, I think this is a nice frame for us. Now, it's interesting with these holes because they have an impression and then they have a white peak in the center. They have an impression, so that they all have the similar kind of structure. Okay, so I'm going to step through this from this point, and you're going to see something that is absolutely breathtaking. But what I want you to do is to bear in mind what I had as the title for this presentation today, which is hopefully here. No, it's not there. Okay, all right. Dear. Well, I want you to have in your mind, look at this group of three that are together, and I want you to consider this group of three that I showed you earlier. This one down here. So this group of three, I want you to consider that, and this group of three over here, and see the intense line around the top there. Okay, I want you to consider those two. This, I believe, being created by a Magneto hydrodynamic system with EVOs that are able to travel through material, and this is in the hydrodynamic equivalent here. Okay, I'm going to step through. Now what you will see is you see this grey area up here. It's not grey on frame 983, and then on frame 985 it's grey. Okay, now watch what happens. There's a grey thing here, and it almost looks like it's spinning around what was a point there. So I've gone back to 985, I'm now on 987, and then I'm on 987. Something goes in this pit. There's another one still up in this pit. Now what happens is, I don't know why this is a little bit blurry. Why is it a little bit blurry? Okay. Maybe if I come out, it might be just too much for it. Okay, all right. Anyway, there's a grey blob in this pit. There's a grey blob in that pit, and later on, there we go. Okay, so I'm going to zoom in, and where's our group of three? Here's our group of three. So here's our kind of yin-yang one, well, like infinite symbol. But here's the group of three, right in close. And you can see a torus comes into the right-hand side one, then it bleeds into the next one, and then it jumps to the third one, okay? Now, what's happening is it's spinning around there, going around into this one, and you have a gap between here and here, between here and here. And this is exactly what we saw in the early Vega experiments, where the frame, in this case, I think it might be 240 or 120 frames a second or something, and it's slowed down to 30 frames a second. But for whatever the period of time that the frame time is, the exposure is not for the entire sequence. And so you have a gap here and here, which should be filled in by having a better frame on there. But here's our torus in here, and then it's blending into this one, and then it blends into this one. And you can see it sits in that one for a little while and then goes off. So maybe at this resolution, it's maybe this one a little bit better. So here we go. You can see it maybe a little bit clearer. You can see it kind of dancing around. There's a bit over here, then the next frame it's here, and something appears here, then it goes around, and it goes over here and around here. So I believe what you're seeing here is an almost exact equivalent, and I'm going forward and back, except in this case the system is extremely dynamic. So whilst these structures are attracted to these resonant areas, they're not perfect. Whereas in the case of the Lion reactor it's not moving around at all. However, I will tell you that the crummy power supply bought off eBay, used to power the little robot like this, Alan Goldwater determined it had a 40-something kilohertz ripple on it, the same roughly as the ultrasonics in this tank. Was that important? Was that important to create the structures that you see on the right here? Was that slight ripple important to do this work? I don't know, but I know that we weren't able to replicate it, but that we did several things wrong. At the time we thought the peak temperature was 850 degrees, but it was actually 1050. So that straight away doesn't get to the temperature of creating cold neutrinos according to Parkhomov. And we had a thermometer sticking out, so the actual structure of our core was different, and we had a stable power supply rather than the power supply with a 40 kilohertz or so ripple on it. Anyway, so that is the main hydrodynamic structure I want to show you, and then I'm going to play this out to the end, and you're going to see something really rather special. Dum! Did you see it? I'll wind back a bit. Going to go back a bit. Okay, so what happens at the end there is that almost instantaneously, when the sound stops, whatever's moving around in those grey blobs either deposits an air bubble or deforms with in really intense shape the structure of the aluminium. And you can say that many of these may be air bubbles that are stuck to the surface. But what is this? What is this here? What are we seeing here? If I can go to it, where is it? There. What is that? What is that you're seeing there? What is that? Now I'm going to step back to when it's formed, and you will see that it's formed almost instantaneously when the music stops. Literally when the music stops. So I go here, right? Doing. Doing. So these could conceivably be bubbles. This looks like it's deformation in the aluminium, and it's not the only one, by the way. If we go to the right here and we come down here, there's another one right here. Now step back. And in this case, you can actually see the structure coming in as a shadow here just before it forms. Now, Matsumoto did say that these structures are generally spheres or tori. And the interesting thing is here, we have two tori. We have this one here and this one here. They are the same diameter, but when the music stops, the actual diameter of the ring is thicker on this one than it is here. Obviously, there could be a range of different parameters that led to that. But what we can also say about the spherical either deformations or bubbles of water or bubbles of gas on the surface is that they are a range of sizes. So you have small ones here and bigger ones and a very big one over here. And this one up here. So, you know, a range of different sizes. And the interesting thing is that it's literally as soon as the music stops, there is this massive deformation here and there's deformation here. Whilst the music is playing, there is deformation, okay? Principally in non-conforming areas. But when the music stops, these things, they literally stop where they are in time, and they either deposit a bubble or, I believe in this case, they are causing a toroidal deformation. So what do we think? What do we think? And at this point, I want to start bringing in some other imagery from other experiments. So I think that the bubbles are formed from cavitation, either in the water or on the surface. These adiabatically compress to nanobubbles. The nanobubbles aggregate, but you would imagine that if they were in a point of high energy, they might be getting bigger and smaller as they're excited. What they might do is aggregate at a point where you have sound cancellation, so interference, where you have, say, phase conjugation. You have a 180 degree out of phase sound wave or light wave, for instance, if you were thinking about a different system, or a phonon shock wave. And so what I'm thinking is that in those locations, they are effectively compressed. It's either on the maxima or it's on the no energy. It's one or the other. And what happens is they are confined by that point of field crossing or phase conjugation. And at the time the music stops, they then suddenly expand out. And so you are immediately seeing either their impact on the aluminium, the impact, if this is an actual impact shape. And so, this is so fresh, I'm just asking you to say, have a guess. Is this an impact mark? Is this an impact mark? Or is this, and this one actually looks hexagonal, by the way. I don't know if you can see that. Maybe it's not so clear. It's got a little bit of a hexagonal look to it. Hexagonal, there we go. Is this an impact mark, or are they just water bubbles? Sorry, air bubbles that are attached to the surface. My first thought was these are definitely air bubbles, and this looks more like a toroidal impact or deformation on the aluminium. Yeah, I think when the sound stops, there's a loss of intertoroid coherence. But when it's happening, when the music's playing, you can still get damage. And that might be where you, for whatever reason, some damage occurs somewhere else. And it's like the butterfly effect. That causes a new sound wave because of the explosive disruptive event. And that disrupts the phase conjugation or the standing waves in there, and causes other ones to be disheveled and cause damage at another point. So I think as the process is going, you can see these different things. So I want you to look at these kind of yin-yang structures, and I'm going to show you a little library of things that I put together earlier today for this presentation, because I think it's quite important to do that. So this is on the Lion jewel. So the Lion jewel was a very bizarre feature that was on the inside of one of the Lion reactors, and it was completely unaffected in the same way that the rest of the reactor was, but it had this kind of like almost this shield, this kind of like white layer to it, which was not the same as the rest of it had. And then it had all these spots all over it. And when you examine those at great detail, you see that these spots are actually not as simple as they first seem. So let me see if that's the same image. Is that the same image? Yeah, okay. And you can see actually that on there that some of these are they're similar to the structure that we saw on the Hutchison effect, but you have a raised area in the center, and almost like it looks like a hexagonal structure with a parasol on it. And you see a number of these, and we'll come back to this one in a minute. This is a dual one in a magneto hydrodynamic structure with this tail, and this tail is very important, and I will come back to that in a little while. But these structures are all over this, and sometimes they have these black spots in the center. So you've got these pairs, you've got these pairs, you've got these pairs all over there. And on the edge, in different angles, there are yin and yang ones, innies and outies. So maybe I've got one with the edge here. That's the dimensions. Yeah, that's the... Okay. So the whole surface are these affected areas, these toroidally affected areas all over this structure. And we saw the same sort of scale of effect on the Hudson Fracture sample. And I have some images here from that. And again, you've got these, if I come up here, I think, you can see just what we've been seeing on the aluminium. You've got these hexagonal shapes with the dimple either going in this case, or out in this case. This is kind of like a bigger one, but the whole thing is covered with it. And sometimes it has a crystal of some type growing out of the center. Interestingly, these crystals tend to be some type of quartz, as from what I recall, which lines up with what was observed in the Lion large structure that we were discussing earlier. So again, you've got this little crystal right dead in the center with the structure around it. And I've got some scales on here. So you have this image here, and you have these hexagonal structures overlaid in the Magneto hydrodynamic structure. So here's one. It's been mashed up by another one, but you've got an outie and an innie here with the hexagonal, and it's in this Magneto hydrodynamic structure. And if you put the scales on there in this image, you can see that these are a particular scale. So here's an innie, here's an outie. And I have a comparison actually between the Lion jewel, which I shared many moons ago, here, and the edge of the reactor, the jewel in Lion. So you can see that this is the edge of that piece that I showed you earlier, and it has these innies and outies all over it, and the same going across the edge on the Hutchison sample here. You can see, and in fact, I think I showed you earlier that there is a yin yang, and there's an absolutely perfect this structure over here, this kind of circle that you have where you have two together, and somewhere here there's an absolute perfect one like that. But anyway, it's essentially the same kind of effect that's going on with the Hutchison effect, that's going on in this ultrasonic tank, and that's going on with the Lion reactor. With the interesting thing is that the Lion is basically, this is the quartz liner, and it's nowhere near it is near the active material, but it's not connected in a way that you would ordinarily think it would be affected in this way. And so it's like one step between the water tank directly being affecting with the ultrasonics the aluminium, and then the Lion reactor affecting this quartz, to the Hutchison effect, which is like basically it's on a piece of metal on a plastic crate. Okay, so then I want to show you some images of lily pads, and these are a Mars gas exposed polytetrafluoroethylene sheets. And in this you can see again these same kind of structures, but between the two structures, the north and the south, you have a carbon filament. And this is interesting because obviously polytetrafluoroethylene is a fluorine and carbon polymer. And so it's essentially saying that the carbon is made into straight carbon in the center here, and produces this structure. Okay, and here's two that are closer together, and you can see the link is closer together between them. And I've got a range of these images from the this particular test with the Mars gas. I called it lily pads. You can go and see the video where I look at these in great detail. This is the titanium, and you see these same hexagonal structures on the titanium that was exposed to the Mars gas. Here's a pair, and they have different colors because of the level of oxidization on the titanium. And so there's that, and that's more on the jewel. And then I want to show you this particular feature down here with this pair, because this, in my view, is very, very significant. So let me see if I can get the image I want to show you. And it is here. And I want to group those. Okay, so this was from our last presentation, and what you are looking at here is something that may not have been obvious, and I'm pretty certain it wasn't obvious to Roger Stringham and Tom Claytor and the other authors. But if you recall, This is some palladium 2% silver in deuterium oxide, and you've got some general cavitation down on the bottom left here on both of the SEM images and the EDS image. And in the center, they found this agglomeration, and this is the center where all of the energy is focused, because remember they had a cylindrical chamber. So all of the half lambda main resonance across the chamber is going to focus on the center. So the peak energy is at the center. And they took this structure off, and they found that they had this hole underneath. And they just think, oh, well, that's a hole, okay? And I think it's far more significant than that. I think that this structure is what I called this the structure, the pretzel, and at my ICCF 22 presentation. And I said I'll be coming back to this structure in future presentations, and that I believe this is very important to the way how a lot of synthesis works in LENR. So I'm going to go back and show you why I'm saying that. And that is because I've seen it in many different experiments, and I will do a whole video on what I call the pretzel. But I specifically called it a pretzel because of observations in Alexander Parkhomov's reactor. And this was one which was just beautiful because it was a three-dimensional structure of it. So this was in Parkhomov's 225-day LENR reactor. The LENR reactor that to date is the longest running that has had all of its details shared. He shared samples with about 9 different independent groups all over the world with no conditions on how they can test it. And in the core felt material, I found this structure, which is composed of a number of different rings of tubes of fluffy carbon in this pretzel structure. And it's the same basic structure as this heart shape here, and it's the same basic shape as this lion jewel feature that I was pointing out earlier. And what is it? This is a hydrodynamic structure that we've seen in absolute massive scale at the start of this presentation, and then the 2 center points, and there's material that's being thrown around between here and here, as I was showing you in these images from the lily pads. So there's material that's thrown around, and I was showing you in the experiment here with the material being thrown from one side of this structure to the other, and being aggregated on the top of here, which we got on the SEM, which we've got here, which is because you have material going from one side to the other. And this here, in my view, this material going around here actually creates its own kind of vortex. And you might consider that there is a vortex going in a direction from here. And if you look at this, there is a vortex, and this has its own effect. Or is this just 3 that are joined together? Whatever. I'm saying that this is a very important structure because it appears in many different places, and I'm going to focus again on this particular structure because I have a good number of images of it. And let me just get that core felt. So here it is. It's rather beautiful. I've got it in different scannings here, different ways to look at it. And what happened was, actually, if I can find the original image somewhere, where is it? It was further out. So I was further out, so you can see it up here. It's blurred, actually, because I'm looking at the focal plane on here, but it's blurred. And I caught it over here, and then I went to go and have a closer look, and then the entire structure I could move around with the electron beam from the microscope. This entire structure, so it's like 250 microns across, maybe 300 microns across, and just by shooting the electron beam I could roll it around. Okay, so let me go back to the beginning here. And so you can see here that this is it's swept up these silicon dioxide felt segments here, and but it has these fluffy carbon material that's looped around. And if I actually go to the other side of this, because I turned it over, in the center of this area here, you can just see a glistening sphere. And I would imagine there's maybe one there, but maybe not. But there's definitely a glistening sphere here. And if we go to the other side, you can see the sphere very, very clearly. So I'm going to zoom into that. You can see this sphere here. And what I do is I go in and I use the SEM to look at that in detail. And I have it here. And the interesting thing is that that sphere, so I look at three areas. I look at the fluffy carbon area, and it's 78.5% carbon, 17% oxygen, so that's quad alpha, triple alpha, quad alpha, and then we have a little bit of silicon and an itty bit of nickel. Now, the core center of this reactor was silicon carbide. So it's not surprising that there's carbon in there. It's not surprising that there's silicon, especially since these are silicon dioxide. So everything's there. The interesting thing is that this sphere that is at the center has calcium. It has calcium. And the calcium was also, as I showed you earlier, observed as an unusual element. If I can find the window. Oh. Where is it? The calcium was observed in this. If you remember the calcium here, this is the unusual element that's in these crystals. Okay, that's the unusual element that's in these crystals. The rest is either in the reactor, in the air, or in the what do you call it, material. So the DEC alpha, and calcium is very regularly produced in LENR experiments. And the interesting thing is it is produced on one side here, and it is produced on one side of this structure. And also it was produced in the triangle. I don't know if I have, do I have the triangle in this presentation? I don't. It was produced in, oh yes, here. It was produced in this triangle here. So you have oxygen and carbon, but calcium, 6.4% here in this triangle. And so the calcium is something that seems to be synthesized. It was synthesized in what I call the pretzel, which I believe is a magneto hydrodynamic structure. And the material that's swept over here also produces a distortion to one side. And you may consider that this could it produce a magnetic beam going in one direction? Because if you look at the work of Shoulders, those initial images from his 1986 book, EV, A Tale of Discovery, he has two EVOs that are spinning around each other in free space. I would imagine that one of those is a yin and the other one is a yang. That's a magneto hydrodynamic structure, and they are spinning around each other. And they have, because they are even faster spinning material in their core, they might be projecting a beam out in a direction. I don't know, I'm just speculating here, but I'm trying to give reason potentially for this repeating structure that I have seen in so many different experiments. So that's one thing I wanted to share with you. And before I go on to the last couple of things, I wanted to share a video here. So is there anything else I wanted to share from this? Hutchison. No, that's about that. So I wanted to share this. If it's going to show it to me, it's not going to show it to me. So I'll switch frame and I'll load it into QuickTime. Any questions at this point? Why is it not loading? Okay, do it somewhere else. What happens to the fluorine, Gordon? I suggest that it might be consumed, and is other data from the interaction between the titanium that was exposed to Mars gas, where it touched the fluorine and there was the explosive event, that there is a plasmoid that actually caused that crystallization that we looked at in Alan Goldwater's Magic Sound Lab, and then we went to Madison, Wisconsin, and they verified these alpha conjugate nuclei filaments coming off as spikes off those beautiful quantum crystals formations. The actual structure that probably caused that explosion, you can see it burrowing in to an area, and as it goes, it's leaving chunks of fluorine, which are alpha conjugate nuclei, and then it gets to the end and there was an explosive event that caused that thing, and I will do an entire different presentation on that. It's absolutely stunning, that data. So it's just really stunning. So I think that the fluorine was consumed, and I think that the EVOs are consuming the fluorine and maybe reorganizing it, because fluorine is firstly it's a single isotope, it's 19, and so therefore if you're going to get it into phase and coherent, it's going to be easier. And plus also it's an NMR nucleus, which means that if you had a strong magnetic field, it would respond to it. And so you know, that's my. I actually think fluorine is a very good Lena fuel. Yeah, Peter, thank you for your video. This is what I've been talking about, is the fact that the video you shared shows the same kind of hydrodynamic structures that I have been saying are the magneto hydrodynamic structures that are occurring in the effects that we see in various Lena systems. And the Russians call, or Shishkin and his team at Dubna, and if you look up Dubna, they call it Dubna Science City. They are the nuclear experts in Russia. That it's like a whole city that does nuclear stuff, and they, if you go and look at many of the heaviest elements that have been synthesized by like taking californium and then firing alpha nuclei into it or something like that, many of the heaviest elements have been produced in Dubna, and these people are very serious, and they call this a class of radiation, exotic vacuum objects, they call them magneto-toro electrical radiation. And the neutral form, which is the ones that come out which are black EVOs, they call them string vortex solitons, and they are the ones that they say are likely, because of the way they interact with beta isotopes and so forth, that have at least in part in them a condensed cluster of are a soliton of condensed cold neutrinos. And so, you know, because they can travel through things but also carry ions, and so for that's what they say. And what you're seeing is something that supports that definitely solitons are involved, and definitely that there are magnetic charges involved. I think in the coming days and weeks we're going to get higher and higher fidelity imagery and videos of these processes, but I think already there was enough material to show the hydrodynamic equivalent of the electromagneto hydrodynamic structures that we've already shared in the past several years, starting from late 2017 and much from 2018 onwards. So calcium is dec alpha, and it's the last magic nuclei that is essentially purely a isotope that is formed of alpha particles. So it's an alpha particle conjugate nuclei, and it is essentially 10 alphas. That's why I call it dec alpha. It's 20 neutrons and 20 protons. I think with looking for magnetism in the aluminium, you're going to need a Hall effect microprobe, and they do exist. So, have at it. There are so many ways that you can investigate what's happening in the LENR world without even creating any LENR in the hydrosonic world, and get a better understanding of what's going on, because it is absolutely certainly that it is magnetohydrodynamics that's going on. I think Solin absolutely nailed it in terms of the visuals that he drew into his October 1992 patent application, which was awarded. And Shoulders showed the fact that these pairs come together and they spiral around each other and they burrow through things as pairs or individuals, but they often pair up. And I think there's a good reason. In fact, if you look at that classic image he has of it burrowing through lead glass, you'll see there's a small hole and then there's a field affected area that blends into each other, and it looks like this same kind of shape. Are we going to see one place losing matter and another region gaining? Ron, yes. And this is one of the challenges in low energy nuclear reactions, is that if you package material into an EVO and it goes into black mode, it can teleport that from one place to another. Okay, and then you could, if it's taken it off a steel wall which has chrome in it, and then it puts it on one of your anode or your cathode for some reason, then you can't say if your cathode was copper that the elements in the steel wall weren't transported by an EVO that was white, grabbed some material, went black, and then went over and deposited it on the cathode. This is actually a real problem in LENR, which most people don't even consider. They're all for getting rid of reasons for contamination, but you can do this with these things. Is the pattern of continents partly due to the yin-yang dynamic writ large? Maybe. I'd certainly say the shapes that I was sharing earlier are something to do with the the two sides of the heart, the push and pull of the heart. I've got some of those MagnaView pieces, but they're really not that sensitive. It's just not enough. You need a very sensitive micro Hall detector, Hall effect detector. Bob, is this like a conservation of energy that arises coherent systems? I believe the coherent part of it is able to convert matter almost effortlessly from one form to another, and from energy to matter and matter to energy. So I call it the Monopole Clutch in my Russian presentation at 20th of September last year for their 26th conference or whatever. But I called it the Monopole Clutch because to give a sort of a nod and a wink to Shoulders that called it the Universal Clutch. And he is saying that this gives us an ability to interact with the vacuum. And in fact, he says that every spark discharge has an evo at the front of it, and it can project into the vacuum and tractor its way through the vacuum. And what is the vacuum? Well, there is stuff in the vacuum. Okay, so I'm going to show you a video now, and remember what I was saying, that I think what you're seeing in LENR systems and is an analog of, or rather in the hydrosonic or the ultrasonic systems, is an analog of what you're seeing in LENR systems. It may actually get to the energy levels of being able to do LENR, but what I've shown you today is mostly, in my view, hydrodynamic processes going on. And that being said, if you have these structures, they still are highly energy condensed toroids in there, and they are doing damage, and they do damage during the process of the ultrasonic exposure, and then something very different happens at the end, and I've argued that that's because whatever's keeping them compressed, whether that's at a phase conjugation or a phase or wave interference node, a zero-sum node, or whether it's at the maximum, the point of high Q, the point of maximum intensity of energy. It's one or the other. When the music stops, they either immediately are coming out as a bubble, or they're coming out as a damage pattern in the aluminium, in sphere type shapes of various sizes, and toroids of various diameter on the toroid ring. And so something special happens when the music stops, and damage or something occurs at that point. But some damage can occur during the experiment. I'm now going to show you this video. You may know what it is. So what you're looking at here is John Hutchison's aluminium boat, and it's sitting in a plastic tray which has water in it. And as he's using his effect here in 2007, there are actually ripples on the water. Okay, now I've already discussed that oxygen, which can be dissolved into water, is highly paramagnetic. So it's not surprising that water gets affected by this, and I've said that that is part of the process, or why water is involved with so many exotic energy technologies, and specifically it is oxygen in my view. But what you will see here is not only did you see the plasmatic type effect early on, that when he turns off, so you've got that plasmatic effect here, but also when he turns it off, sometimes you then have the plasmatic effect occurring after the turn off. So it's turned off now, and the plasma is doing its wildfire. Look, it's going around, and the energy is turned off. It's still going over here, and he's not got the thing going. And now it's stopped, and he turns it back on again. Now it starts, and he's turned it off, and it's burning at both ends of the boat. It's not burning, it's a plasmatic effect. And I believe the exotic vacuum objects, which are most likely to cause themselves to occur on the surface, are doing this plasmatic effect as they dishevel, and they are causing what looks like fire or some sort of plasma going on. So again, it's the bit at the end here. At the beginning, he's just warming up, and some events happen, like it does in our aluminium foil in the hydrodynamic model. But as we get to the end here, he turns off the power here. He turns off the power, and the plasma's on its merry way. It's on its merry way. There it goes. No power's on. Okay? And it's going here, no power on. And you can hear, there's copies of this on the internet with audio and stuff. There we go, the power's off. And specifically in those last occasions, it's only when he turns the power off that the flame occurs. So what I'm saying is, in the Hutchison effect, they are creating exotic vacuum objects. This was the thing that Shoulders got from studying John Hutchison. I think you've seen the hydrodynamic model of those. You've seen that we've been able to show a Magneto hydrodynamic model has damaged various materials in various scenarios, principally a lot in the Lion reactor materials, and that this doesn't necessarily stop when you turn off the excitation, that these things can continue to do their work, like they did in Bogdanovich, like they did in John Dash's work, like they did in Savvatimova's work, like they did in Sviatomenko's work, like they did in Piantelli's work. They can continue to act in the material. But like you saw in the hydrodynamic model, when the phase conjugation or the summation or null zones in the interacting electromagnetic or scalar fields are lifted, the exotic vacuum objects that are kept at bay, they're confined into their little point in space and time, suddenly are free to go into interact with the material. It might be that they are compressed into such a small area that they consume all of the matter and interact with all of the matter into the area that they're confined in. But then when the field energy is released, they expand to their free space hour dimension size, and then they are interacting with vastly more nucleons, and it is what you're seeing in this plasmatic effect is them condensing more nucleons into their structure whilst they're in between this very stable and confined state and into another state of stability. It's not just when the boson over happens. If you look at this video, it's traveling around and doing things, and this is exactly what Bogdanovich observed 2 days after his plasma flow discharge experiments. So here we go. The vibration is on, and then he turns it on, and there we go. There's a little flash. There's a little flash at the other end. Now it's going. It's going whilst it's on. There we go. It's turned off, and the plasma is going at the back of the boat there. It goes all the way down to the far end of the boat. Two join up. One bounces off the other, and then it starts up again. He's not done anything. But there's obviously an energy area over here. There we go. Doom. And I'm telling you that what you're observing here is not the only time this exact effect has been observed. I'm just putting it that way. Okay, so with that, are there any questions? I think we're pretty much done for today. Was it salt water? I can ask John. John tends to watch these videos, so maybe John, can you let us know if you were using salt water there? Yeah, this is St. Elmo's fire, I believe, quite possibly. Yeah. You know, it's a ball lightning or exotic vacuum object that is disheveling, and it's coming out of its own coherent confinement. And the substructures are then eating their way through other material because they're not bound into the whole. Why is it glowing orange? It's glowing orange because it's emitting soft X-rays or whatever, and they are interacting with the air and causing it to ionize, and that is the plasmatic effect. It's not burning per se, it's ionization. Okay, so I think someone's got a boring question here from Jason Cook, but it's sometimes hard for me to see the mouse pointer icon. Could you select a larger one? Yeah, I will do that. I'll try and do that. I did consider that. I'll try that for the next video. If I shake it very hard, it gets very big, but then it's only from my view, really. Let me see if I can do that for the next time. Okay, well, I think probably I'll do a quick summary. What we have done today is we've looked at a video that was produced by Peter Middleton. Thank you very much, Peter. And it is using something like this particular kind of, if that'll come up there. This is a device that you can buy in the UK. If it's going to do it, it's going to do it. No, it's not going to do it. Or is it going to do it? My computer's being very slow. Very slow, very, very slow. Okay, it's not going to do it. We looked at a wide range of structures that I believe are magneto-hydrodynamic. Starting with this structure on X-rays, the fact that it's a magnetic charge, that several parties think it's a magnetic charge. Some parties think it is a magnetically excited neutrino. I saw this first, this loop structure, and I couldn't understand when I was looking at this, because how did this occur? If it wasn't, I thought the loop might have be a torus and that it might have created the whole sphere, but it didn't make any sense. And it took me some years to work out that actually these were magnetic charges that were caught on this ferrite, which is magnetic, and they were then sharing material between them, and they produced this carbon sphere in the eye of one of the Pac-Mans at a different scale. These loop structures, which the mirrored sides of these in this, and then the cannon structure here. And again, when you look at this material here that's ejected, that went on this number 19 here, if you look at it, 19 when it comes up, 18, 19, it has zirconium in it here. And zirconium's not in any of the reactors, and in fact zirconium is I think it's 2 times calcium oxide, and so it's kind of like the next stage on from synthesizing calcium. But also this rod has what does it have? It has a range of materials. And then we looked at how I came up with this structure, starting at this being 50%, rotating it, and the reason that the size of the ring in the center is the size of the ring in the center is because I had to match up with the outside field effect and the inside hole, and that is more clearly demonstrated here, where if you look here, there is a white area in the center, and on this one there is a black area in the center, because one is north, one is a south magnetic charge. And I then had to have the 2D diameter of the center centered around that in that case, and the same in this case. And so that meant that it was only 1D outside of that, and then that is the radius it produces, and it exactly matches. So when you make this the right size, then this matches, and so on that basis I went forward, and it kind of fitted with all of these different structures here. And without modifying the model, you end up with this, where this structure is 50% into the surface and it leaves this ring. And then we saw this structure in the SEM on the 10 yen coin affected by the Amasa gas. And it's shifting the paramagnetic copper, but not manipulating the much lower percentage, up to 4% of zinc, that's in the 10 yen coin. And then I explained in this particular presentation a range of different magnetic charged based technologies and how that would work to remediate nuclear waste in exactly the way that was done by Ewell Brown in his demonstrations in 1992 to US politicians, and how it would explain this. And then I went into the Solin patents and how the observations that he had in his October 1992 application were exactly matched as magneto-hydrodynamic structures that he saw in his low vapor pressure melting point materials like zirconium and molybdenum and tungsten that he used in his reactor, and that various things that he described in his patent were realized in our Marsa gas testing, which means HHO can do what Yule Brown said it can, and hopefully, which we wanted to do last year, we will be able to do the testing and confirm that that is actually the case, and that we can do radiation remediation very, very quickly using Yule Brown type brown gas and that kind of family, and also a Marsa gas. So that, and maybe one is better than the other. I suspect a Marsa gas is better because of the way that it's produced with the cavitation. So there's a little bit more interesting going on there. But anyway, that's that. And then I went through a whole list of examples of materials that showed these kind of effects, and this was the comparison between the Lion reactor and the Hudson Fracture sample with these exact structures that we are seeing being produced in the hydrodynamic model, and I went through a lot of various images on the fracture sample here, and where I scaled those, for instance, and I showed the innies and outies that you get on these structures. So you've got this innie here and this outie here, and there's an innie and an outie in a pair in this group here. It's a little bit damaged over here, but exactly what you see, and this therefore would explain why in your Hutchison samples it kind of jiggles around. The outside of the aluminium jiggles around, but then there's modes at different resonant modes. I've got one other image. I've got to show you this. Where is it? Where did I put it? Where did I put it? Oh, I've got to show you this. Let me find it. Where did I put that? Not there. Okay. I might have it on the fast USB. Let me see. Talk amongst yourselves. I just want to, maybe if I can remember what I did here, get this out to you. There's the last money shot. Oh, damn it. No, I've forgotten what I'm talking about. No, I'm not. It is not there. I thought I put it in there. Okay, I just need to put in a different drive. So let me do that. I don't know why it's not there. I must have put it in a different directory. Okay. If you have any questions, ask them now, or forever hold your peace. Okay, all right. Yeah. It's another area on the sample fracture, but what I wanted to do is to show you by showing you on a Hutchison sample. It's actually a video that I did a year or two ago, a year and a half ago or something, and it shows you the different frequencies that are on the Hutchison fracture sample. So I'm not sure why I can't find it there, but anyway, I'm sorry about that. What are your questions here? So, Ron Muckle, yeah, weird fires. Yeah, it's funny you should say that. Yeah, apparently someone came out of a building and they saw weird fires. They felt a field change or something in the air change, and then absolutely every vehicule on the street produced a weird fire, and then they could see where they're going. That's a testimony. Interesting, isn't it? Evo store energy. Yes, Corky. Is this related to weird deposits of material outside target zones? I do think that this could, you sometimes see these metal axes or something, and they're found in the bottom of a quarry, and it's like, how did that happen if the civilization is only this old? Well, if it went into a ball lightning and the ball lightning went into the ground and then dissipated, it could deposit a metal tool a long distance underground, and you would think that someone had lived in the middle of this quarry rock, but no, it's been basically teleported there. Are those, actually, you asked a question, are those areas polarized? What are we referring to? Just let me know what you're referring to as I read down. Yeah, you can get water levitating there, and I think the reason is that water will contain oxygen. It obviously contains it in the molecule, but it contains oxygen, and the exotic vacuum objects can build up in the water, and then it becomes, able to levitate. And actually anything containing water, really. Gardi, don't wait for government. We can do it. Already in the last few weeks, we've seen so much in the plasma area, and just by another person trying the ultrasonics, you are seeing things that have direct analogs in the magnetohydrodynamic world, and so you can almost predict what you're going to get in the electromagnetic magnetohydrodynamic world by seeing things. So if we see something new in the hydrodynamic world, then without any transmutation questions going on in there, we can expect to see those in this magnetohydrodynamic world. Cheetos, yes, Cheetos, things that produce that same orange kind of plasmatic effect, but actually aren't hot, yes. There are even researchers that think they've got their own private universe that are seeing these kind of glowing things, and it also causes failure in their reactors, but it's not a thermal type failure, it is a disruption of material type failure. How would a wormhole work in terms of travel? Like, how would I open one to my intended location. I don't know really, but you can get yourself into a quantum coherent bubble, and because the space-time inside does not obey the laws outside, perhaps you could squeeze it into an extremely small point in space, like these bubbles go in the hydrodynamic system that you've seen today. And then you could fire that through the wormhole between two very large EVOs. And when you come out the other side, you just need to kind of like come back into our free space. I like to think of, you know, maybe what's going on in that 7 by 2 by 2 by inch iron column that kind of twists and bends over, and the material gets sucked into the center of the center. When you understand what's going on in this technology, what you're seeing in that is just not surprising. I'm referring to another very famous Hutchison 2007 experiment. Yeah, I think heavy Brown's gas, Amasa gas, MHHO will be the best direction. I think it's like much easier to use. What I envisage as the future is, you could have modular nuclear reactors, and by the nuclear reactor you could have a generator of Amasa gas, and you could just use that to be there on site with a gas tank already. Because when I was with Amasa, he had a tank there that had been there for I think 12 years or 10 years. It had barely lost any pressure, and it was still the right kind of gas. And he had another one which was containing the gas for 3 years, and it was sliced up, and they'd done hydrogen embrittlement testing on it to see if there'd been any sort of classic hydrogen embrittlement, which you normally get by trying to store hydrogen, and that wasn't the case. And I believe it's because it's forming these clusters, and the oxygen plays an important role in doing that. And because the EVOs are very magnetic, they cluster this material together and encapsulate the atomic hydrogen, and in fact basically it's Lena in a can. It's Lena in a can. And I can tell you, I have unimaginably amazing data that I will get out. There's more work to do, but it's just breathtaking with what happened with the hair thickness indium and the thoriated tungsten rod. I mean, the data in that is just breathtaking. But basically, it's low energy nuclear reactions in a can. We saw a polarized hexagon pattern in the aluminium of the plasma reactor. Yes, that's true. Yeah. Many of these structures are taken under polarized light. Not on the PTFE, on the Amasa gas exposed PTFE. Would it be possible to put a nail with magnets on it partly into a sonicator in order to collect some of the EVOs in it? Well, actually, the slide that I have here, if I show you, if I switch here, when I was describing this, I'm saying that the line reactors have a 2.5-inch ferromagnetic bolt in the core of the heater coil. This would allow build-up of magnetic charge at that point and up to the iron Curie point of 1043 degrees Kelvin or 769 degrees C, and in the nickel reactor up to 353 degrees C. I'm saying that this soft iron bolt, it aggregates, and when you actually look at the reactor core, the bolt is down here and it goes up to this point. And in one of the line cores, there was a massive damage at this point, and I'm thinking that the bolt actually aggregates a vast amount of these magnetic charges that are produced in the reactor before they suddenly release it, and so I think that what you're saying in a sonicator, it could do a similar thing, and that's a pretty good idea, actually. Yes, I agree, Peter. Just a ultrasonic transducer under closely spaced HHO plates. In fact, there's a patent which basically claims the same thing as Roish and Amasa that came out 10 years later, and is essentially just vibrating vanes using an ultrasonic driver rather than the mechanical, more large physical mechanical driver that Roish and Amasa is using. So this has been done, but I agree, and Murray B. King suggests doing something similar to that, and really it is about producing, I believe, but when you do the cavitation, you cause oxygen and hydrogen to be separated, which gives you oxygen. And oxygen allows for the more magnetic clustering and production of the heavy material, in my view. Tungsten, as I've said, is a very long, heavy nuclei, and I believe that if you remove all the electrons from some nuclei, they fall apart. Also, the EVOs are very aggressive at getting into something that has a lot of neutrons, and if you believe the SAM model, that where neutrons, and this is a fair thing to say, neutrons decay into an electron, a proton, and antineutrino. If the EVO wants the electrons so much, it might take them from the neutrons, and so you get a fast decay of titanium like that. Tungsten, rather. Of course, tungsten is paramagnetic, and that's very important. And I say that actually in my Russian presentation, that it's important for that reason. And the magnetic charges will therefore be able to stick to it, build up until it literally rips the nuclei apart. I don't think the cesium salt is that important in a Mars gas. We did use it, and I've got some beautiful data that I shared in my poster at ICCF22. This is answering Axel's question, where we had the cesium interacting in a way, and it's very the outcome from that experiment proved that, in my view, conclusively, that the Amasa gas, the Amasa vibrator plates, is transmuting matter. Well, Jason, with HHO in you can't drive a car by HHO alone, because you would end up destroying all the metals. But as soon as you add a hydrocarbon in there, you have carbon, and carbon readily prevents preferentially the EVOs from destroying the metals, because it acts as a preferential boson. It likes to consume carbon, the triple alpha in there, and it's bosonic already. And so and also it's hydrocarbon, and so you have hydrogen in there as well, and so the hydrogen and you're feeding oxygen in, so you have a scenario where you have a quad alpha and triple alpha, but really it loves carbon, and so it prevents it from destroying the metals. How close are we to technological singularity, and do you think Moore's law is dead? I think I was going to hold up an old DEC Alpha chip today, because I remember at university when I was 19, and I'm 49 now,
So that's 30 years ago, if I can do my maths right. I keep getting that wrong. I keep losing 10 years. But anyway, I remember reading about the DEC Alpha, the RISC processor in there, and then I actually owned 4 DEC Alpha machines at an unimaginably hugely expensive price. And then for whatever reason, that technology got merged into the strong arm, which is now in everyone's mobile phones and is now in every Apple that's going to be produced from this time onwards. And this type of technology is so far superior to previous technology, I can tell you. There is easily a Moore's law over the next few years with that family of processors, and I think AMD are going to be moving in that direction. So with regard to technology, I think we are approaching a singularity. I don't think it's one that our species hasn't had before, but I think what you're seeing with the Vega experiments and Ultra, but principally with things like Brown's gas, and when I believe that I can fully explain PAP from end to end, I do some explanation in my Russian presentation about the accident that happened there and what people have overlooked in that accident that points to the same effect going on. But it's the actual plasmatic process which I will discuss in a separate presentation. But all of these technologies, the original sort of Grano, and even before then, back in the early 20s, I think it was, at MIT, the exploding in water vapor discharges, all of these are related to this exact same phenomena. And so when you understand that, water arc discharges and spark plug, all of it is the same thing. It's all the same thing. So I think we're getting to a point of there will be so many people with clarity on what's going on that many people can come up with embodiments. And as I said to people at Aarhus University about 3 or 4 years ago, whenever it was I was there, at some point in the future there will be whole universities that are dedicated to studying various aspects of this technology, and I am a firm believer in that. And if they're not, then what are we doing? Because this is the next several orders of magnitude of ability to manipulate the world around us and deal with the bad stuff and allow people to live with dignity and in a good standard of living. Ultrafine particles of radioactive waste in water pumped through MHHO flame reactor, excess thermal energy, then great bit useful. Yes, Peter. About this global, Corky is talking about you need to get a level of critical mass of conscious level understanding, but people need to see material in such a way that it is so clear that there is no other explanation. When I was sharing these images last year, or sorry, 2 years ago, 3 years ago, whenever it was, at the beginning of 2018, or whenever it was that I was sharing these, when I was sharing these, no one gave me any explanation whatsoever. But they were quite willing to mock me and say that these are relevant. It's just damage, It's just damage. There's nothing interesting. And it's like, really? You don't think that this exact pattern being produced on an X-ray days after the reactor has cooled down, which is not in contact with it, you don't think that that's interesting? And so, it's. And I don't blame them, because they think these things are not possible. You can't have something floating around in midair that you can't see that can do this kind of level of damage to quartz. This is a very hard, very high temperature material. How can something just burrow into it effortlessly? How can it do this kind of hydrodynamic damage to it when it isn't near the reactor? What's going on? So there wasn't even an attempt to address this by the community. a lot of the community just ignored it. They wouldn't even publish it. But thankfully, the Russian community see this all the time as a magneto hydrodynamic effect. But why is it there? Well, I think we're very close to a watertight explanation. Can EVOs consume CO2? Gordon, I believe they can. And in fact, I think in the presentation that I shared the other day, some slides from, and I was looking at the George Oshawa reaction chain, Bockris at Texas, he showed that carbon and oxygen, I think it was carbon and oxygen, went to iron or something like that. He had a slightly different theory to how the iron is produced in the carbon arc in water experiments. Yes, it's a mixture of petrol and HHO. I drove around in a Mazda's car, which is 50% LPG and 50% HHO. And he had I think a little scooter as well that they do. The Hutchison iron bar or the Hutchison aluminium are cold to touch, partly because it's a what goes up must come down type of technology. I want to mould diorite with my bare hands. That would be great, Corky, and I hope one day we can do that. I'm pretty sure it's possible. Space Rocker sounds cool. Slobodan, I totally agree. And I'm very looking forward to working with you when we can later in this year. Same thing happens to my fused quartz in open air burns. What you mean, it recrystallizes, or it produces magnetohydrodynamic structures which have either a dense part in the center or a dense ring around the outside and no damage in the center? Corky, I'm with Dan on the good vibes from you. Knowing what you know about what do you about Elon's approach to Mars civilization by using Starship and chemical rocketry? Is he really that innovative in terms of aerospace engineering? I have some opinions on that. I don't think it's a coincidence that the car company is called Tesla. I don't think it's a coincidence that he has an organization that wants to deal with tunneling. And I don't think it's a coincidence that he is doing something that involves vertical takeoff and landing. I think what you have to do is you have to set up a body that is plausibly a body that could discover things because they're working in the same field. So if you wanted an electric car that ran on its own power source and didn't need batteries, you would do that. But you would want to get everyone else making batteries and designing their system based off batteries, and then you would already have something that replaced the battery. If you wanted to have a system where you designed a whole series of technologies that relied on tunneling, which I argued in one of my previous presentations, you would want to do on Mars. You wouldn't want to build things on the surface. It's a hellhole. You need to create a pressured environment for humans to live there, and you'd want to do that underground. It's just easier to tunnel than to get material, make it so that you can make a sealed thing. Now, if you used exotic vacuum object tunneling technology, you would just be able to bore and you would end up with a completely glass hermetically sealed tunnel. This is exactly what you see in those images of bored through aluminium oxide in the images shared by Ken Shoulders in, I think, even in his book Evo Discovery, where the Evo has gone through and you literally have a smooth glassy surface that would be hermetically sealed. And so that's what you would do. So you would have a company set up that said, oh, I want to do boring technology and blah blah blah, but you have a technology that will come along and you go, wow, they invented that. And then you would have a company that specializes in VTOL and landing, and you would do these dog and pony shows, which are fantastic, by the way. I'm not mocking that. It's just awesome, you know. But you could do the same thing with much better approaches. Let's put it that way. Neuralink, I'm most concerned about, because firstly, you already have a Neuralink and it works through the ether, and it actually, by the way, it works with the same technology. I'll deal with that on my blog in the private area at some point, about how I believe that works, both remote viewing and ESP and love connections and all those kind of things. But Neuralink is more about control and being dependent. And the problem is, and I discussed this with Andrew Johnson a good number of years ago, and I actually have a recording of the call where I said it just worries me that we're moving in this direction, because the silicon chip inside her head is switched to overload, and nobody's gonna go to school today. They're gonna make them stay at home, and daddy doesn't understand it. He always said she was good as gold, and he can see no reasons, because there are no reasons. What reasons do you need to be shown? Oh, tell me why I don't like Mondays. Tell me why I don't like Mondays. Tell me why I don't like, tell me why I don't like Mondays. And that was about the first shooting, mass shooting in America, and it was a girl. She's still alive, she's still in prison, and when she was asked why she went and killed a load of her school friends, she says, well, I don't like Mondays. But I love the prescient, the kind of like foresight by Bob Geldof in that song of saying the silicon chip inside her head is switched to overload. And I envisage a scenario where if you don't vote for the right person, you're not productive enough, you're not the right, let's say, genetic makeup, or you're just a useless eater, when everyone's been encouraged to have their convenience strapped into their brain, oh, it's just going to make it much easier for you to do your job, and then it'll be voluntarily, like things that begin with a V and then sound like scenes at the end. But then you can't go to school unless you have these things, and then you can't travel unless you have these things. So it's voluntary as long as you don't want to live, you know. It will be something that you have to have when you're a child, and when you don't have any choice, and your parents are made to have no choice about it, and you will have this thing put in your brain because it's what everyone does, and then at some point they'll just switch off 7-8 billion people, and it's like, what are you going to do about it? Everyone's gone. You got something to argue? Oh, Slobodan, excellent, great. You must get some higher spatial and time resolution image on that apparently coherent beam that's coming out of your HHO jet. I'm really interested to find out. And also, you could try what the Russians were doing in the 70s and 80s with their plasmatrons, where they had a microwave chamber, they were creating a plasma, and they were firing it through a polycarbonate capillary, and it produced these what looked like strange radiation emissions that were not able to be deflected by a Mach 2 airstream, so twice the speed of sound. And the plasma, normal kind of plasma parts of the jet were not able to be deflected, but were able to be deflected. But these things they almost didn't see the airstream. I would like to see if that kind of similar thing happens. The Tesla logo is literally a monopole clutch. Yep. Jets on a car. No, it will be the propulsion that's used for the VTOL technology in the future that will be used on personal transportation vehicles. It's just setting the kind of, this is what he's thinking about now, and it's from my view, there's a big load of technology that needs to be slowly rolled out to the public, and you need to have people out there that can plausibly invent these things when really they were already invented billion years ago. Yeah, maybe, Slobodan, the plan is to get all the lithium and then use the lithium in transmutation experiments. He's like, come and let us come and bring in your batteries and let us swap it out for another power source that uses 10 grams of lithium for the next 10 years. Actually, somebody who works with Hal Puthoff is in Germany, and I can't remember his name immediately. But he's working on, like, they trap a single electron in a laser confinement, and then they're getting people to see if they can change the spin on the electron or something like that. I think coherent matter, if it comes from you, out of your fingers, and I will argue this on my blog in the private section at some point, and I will go to the science and the data that makes it very easy to conclude this. You are able to emit things from your fingers that are entangled with your consciousness, and if they are absorbed into something else, then you have the ability to manipulate that thing. And I think this comes to all of those concepts about laying on hands and having to touch something first to be able to manipulate it. And Kirlian, or whatever it is, photography, you emit evos from your fingertips all of the time. And this is actually this is touching on some of the other 50% of Ode, which I will get to, but I wanted to deal with the things that first that are specifically testable by anyone in highly repeatable experiments that they can see visually first, before getting to the things that it's quite nice, because there's a crossover actually right now, because there are damage effects that are created by things that no one could see. And now we can see the hydrodynamic model of the things that are doing exactly the same thing in a hydrodynamic sense that we observe the witness marks for in the material that must have been done by a Magneto hydrodynamic system. And we're seeing that in the Vega plasma experiments by Hank and Dave, and we're seeing that in now what Allan Kusk and Peter has done in the hydrodynamic ultra experiments. Yes, Peter. Yeah. And like I say, the work of Yul Brown, which I think I gave a fair explanation for the exact mechanism step by step in my Russian presentation, that was effectively open source because he presented it in 1992 and it was talked about in 1992 what he did, and we're much more than 20 years beyond that, and obviously it was publicly disclosed. And by the way, in his patents, I think it's in his patents, he says that when you transmute the material, the radioactive material or whatever it is, you get mostly carbon, which is exactly what I've observed, what Matsumoto has observed, you name it. That's what you get. You get mostly carbon. Why? And I've explained that. Yeah, Kirlian photos, yeah. By the way, Mr. Hales, this is what is able to manipulate chi, in my view. And in fact, if you go back to historical posts on ECAT World, I've made that clear. My EM system, this is WP for truth, my EM system levitates with 5-volt pulses when sitting above a neodymium magnet and can be controlled through frequency and AM. Any ideas? It may be producing macro evos, which are levitate what? What are you levitating? The magnet? You know, you're saying something. My EM system sitting above a neodymium magnet. If it's sitting above a neodymium magnet and something is levitating, well, you know, something that's very highly diamagnetic can do that, and something that is superconducting can do that, and an exotic vacuum object is superconducting, so I don't know what it is you're levitating, but if it was a piece of pyrolytic carbon, then that would do it anyway by itself without anything else being involved. But if it was something else, if you enshrouded it with coherent matter, which is superconducting, then in theory it should levitate. I think we're getting very close to the other 50% of O-Day for those that have been patient enough. It's been a long journey. I was discussing someone today. If I started by saying everything, just people would think I was flat out nuts, and most of them did. A lot of people did over the last several years, and so it's been wonderful to work with people like Henk and Dave and say, you know, because not only are they doing things on their own, they're very receptive to ideas and what they've produced, and I've been able to manipulate into sequences to demonstrate things by like taking sequential frames that I believe are demonstrating something. Has made my life a lot easier than just trying to convince people by waving arms. It's much easier to just show video, and it's kind of what you need to know, what kind of systems will be able to show the effect, and then show it live, and then show it in different ways, and I think we're getting there, and I think that what we're doing at the moment is we're showing that things that you can't see can influence things that you can in ways you can't expect. And so to talk about the anti-gravity aspects, which are not straight matter rectification, you need to kind of have fully internalized the kind of things that I've been talking about today, and then it will become very clear how those anti-gravity and propulsion technologies work, and there's more data to come behind that. But this presentation today, actually, people probably won't recognize the value in it until we get onto those subjects, because you need to go through that mental change in recognizing that, yes, these things were produced by something that was produced in the reactor, and they were able to teleport through solid material and then reactivate and interact with physical things in the environment. Jason, you say, I drink H2 water every day. Well, I was very surprised that I have a friend here who is she works helping people who are in hospital, and they're dealing with potential grief, or they're going through diagnosis and coming to terms with that. And she just came flat out and said, "Oh, I'm drinking H2 water every day. I've got this little device that makes it." And he says, "What do you think?" And so I just said, "Well, yeah." And I went into a little bit more detail, let's put it that way, than she was probably expecting. But I just thought it was weird, because there is people out there that are waking up to these technologies. Okay, fantastic. WP for truth. If it's involving magnetism and levitation and so forth, the parameter space is really important, what you are delivering to it and so forth, to help me understand within what framework of input and the activity is going on. But I would imagine it's all related to this technology. Okay. Thanks for the detail, WP for truth. Yeah, a method to my madness. Yeah, you have to have a healthy belief in not caring what people think about you when you're doing this work. And the support of a good partner, wife, and understanding children. Let's put it that way. Okay, it's 23:27, so I'm probably going to call it a night. So I have to say thank you to everyone. And I look forward to seeing what you have. Well, thank you, Theo Sampaleno. Please, I haven't seen you on our channel before, so please subscribe. Hit the little bell and notification button, and look at some of the recent videos in the Vega series, look at line videos and so forth, and try and get some contexts. Some ones I would particularly recommend is the one that I started just reviewing here in this presentation, which is the Monopole Clutch, but also look at the magnetic signatures of strange radiation, and the one where I review the coherent matter wave patent of Lockheed Martin, and also one of the ones that I talk about opposing magnets in neutrino. I think it was Hacking the Neutrino Universe. Go and have a look at those. I think those are a good starting point. And look at some of the Project Omar videos as well. Mighty Mouse Girlfriend, yes, the mind has no limit. I agree with that, because I've always said since I was a child that as long as you are of sound mind, and that is questionable in my case, but maybe that's necessity. If you're of sound mind and you're physically able, then most of what stops someone doing something is their own fear of failure. And throughout this journey over the last nearly 9 years, I believe that there has been apparent failure in some of the things that we've done, but they've always led in a direction. And the only thing that it makes it certain that you will fail is giving up. That's it. If you give up, then you 100% will fail. And it's such a pleasure to be able to get the data from these people that have been inspired by the work we've done and other researchers in related areas, and cross-correlate between very many different independent parties, and get a sense of literally coherence in understanding how this technology happens. And for me, and I think for everyone in the coming year or so, maybe 2 years, I think it's going to be a little bit difficult, really difficult for people to come to terms with that this technology is not new. I call it the new eternal fire, like eternal in square brackets. But this is what there is. This is, and it will be the same point at every point in the universe. Thank you. I will wait for your contribution. I just want to say also today that because of the videos that I was sent shortly after I woke up, I got to sleep at 2:30 last night, and from about 6 o'clock I was going through my head, Show sent me an email, Show sent me an email, Show sent me an email. And he sent me an email to do with Matsumoto. He sent me and then I just gave up trying to sleep. And at 8 o'clock, I woke up and looked at my phone, and the top email was from Sho. And he says, I've got some translated papers that you asked for from Takaaki Matsumoto. And there we go. So I'm going to wind down by reading those papers. And so I think we are moving towards a situation where the key papers on magnetic current, new form of electric current, transmuting with ball lightning, radioactive waste and stuff, those ones that were not in his compendium that I already have, which I believe are absolutely critical to humanity, out of his body of work. This is a nuclear scientist through his entire life. I think we're in a position, or we will be in a position, to ensure at some point this year that those are published. Do you think that faster than light propulsion or wormhole generation via EVO principles are possible? I think the wormhole generation is possible. I don't know how far that would allow you to travel. I do think that you can teleport. So effectively, you go. I was describing this earlier. You go into a structure like this, and then you can use an electromagnetic wave to send you. But that limits you to the speed of light. But you can get very close to the speed of light. The sort of technology that I will talk about, I believe, will get us to 0.8 at the speed of light and will allow us to get to Alpha Centauri and back in 12 years, including acceleration and deceleration. Going beyond the speed of light, well, we have already discussed how this is changing the material inside so that it weighs essentially nothing. But even if you're just weighing one electron, that tends towards affinity as supposedly as you reach the speed of light. So what you need to do is to decompress the vacuum in front of you and compress the vacuum behind you. And I believe that I will show that exotic vacuum objects in a certain structure will be able to do that. I have heard of the W. Hoff method for control of internal body, and I believe that it is trainable. I haven't done it. The Stanley Meyer work would be great. Yes, in fact, I have a new web domain that I actually took over. I signed up for it a couple of years ago, 2 or 3 years ago, and I want to structure it so independent researchers can have to work on various threads, where it's ultra experiments or Vega experiments or whatever it is. Brown's gas type of Mars gas experiments on there in a cooperative fashion. I know there are other places over Unity and so forth out there. That's fine, but I only have a certain amount of time to interact, and you know, I've not joined certain forums purely for the reason that I don't want to spread my communications. And so, you know, they are where they are. So I will talk about that in the coming months. And it would be nice to package that information, for instance, either there or on the Quantum Heat website. So as a resource, we are looking to add resources into the Lena Events database. So if it's relevant to the Lena Events database, which Stanley Meyer's work may be, I believe it's the same thing. I believe you are creating coherent matter, and the coherent matter is able to give you gain in the amount of water that you're able to split. Bob, have you ever figured out how you get those mental downloads you get when you're half asleep? Because that's been happening to me, except I don't get complete thoughts. It feels like brain tease. The trick I found is what happens to me, and I've been told that this happens to Alexander Shishkin. I believe it happened to Tesla apparently. It happened to Ken Shoulders. I basically, and my wife hates me when this happens, but she knows when it's happening because I'm tossing and turning in bed a little bit, and the temperature of my body goes up, and I have a vast amount of information coming in, and it's generally comes as a series of I get specific insights, and I just have to get up and I have to write them down. Sometimes I produce an outline for a presentation. Sometimes I write them in a notepad. I write them on paper. I write them in my thing here. and it's almost like I'm not allowed to go back to sleep until I've dumped what I've had. It's kind of like when you have a dream and you don't want to forget the dream, but you wake up and you've forgotten the dream. But you're aware that you're having the dream. You're getting stuff that's not. It might be correlating things that you've experienced in your life. It certainly helps to have a lot of experience, but certainly it would appear that totally new things come in, and you have to document those. Otherwise, you're almost not allowed to go back to sleep again. Once I've documented them, my temperature can come down and I can get back into bed and go back to sleep. And this is the issue for me, because I know how long it takes to get the material together to make a presentation, and to if there isn't already 9 times out of 10 there is already work done that explains the download, but it's work that people are not talking about, or it's you got like 10 views by someone or whatever, but it's absolutely important. And what I sometimes get is just the pointer to look for that information, and so then I go and look for the information based on the download, if you like to call it that, and I find it's there, and it used to freak me out, but it doesn't freak me out anymore. I just go, okay, there we go. I'm just matter of fact about it now. But the problem is I can project out that it's going to take 3, 4, 5 years to get the information out in an order, so that everything is coherent, is consistent. People can see that bit of the situation is explained, and you move to the next step, and it is literally step by step by step by step. I was talking to someone today, like when I think it was in Mexico, when the Spanish galleons were coming up to, I don't know, let's say the Yucatan Peninsula, but I don't know if it was there. The Native Americans, they apparently, the story goes, they couldn't even see the ships. They were there, and everyone could imagine. You could imagine that they were seeing them, but because they had no frame of reference that this was a thing that could be floating on water and then be this size, that they didn't actually see them. It was like, and I found that I've put out image after image after image of physical things that I can see going on in a reactor, with many of the images that I've shared tonight, and 99 out of 100 people have no idea what they're looking at. There's a guy called Musical Hemispheres, and a guy called Artifact who's on here, and so several other people have been actually pretty good. Musical Hemispheres is really quite good at seeing the wood for the trees, as I call it. Like there's trees everywhere, but I don't know where the wood is kind of how I imagine it. So yeah, I mean that's basically it. It's being able to recognize what is being said to you. In terms of Stargate portables, I kind of believe that probably is possible. Ken Shoulders said there's several ways to travel with this technology. You can teleport, or you can copy something, have a copy over there, and then delete the original. You're not meant to copy. He says it's not good form in the spirit world to copy your spirit. So yeah, and I would agree with that. I'm sure if it is actually possible, there are people that would abuse it. Yeah, for me, the downloads happen in a kind of like not really slept state. I'm not awake and I'm not asleep. I'm like in somewhere in between. But it's very, very obvious that my temperature goes up, and yeah. Okay, I really am pushing it, so I need to go. So thank you, one and all. I hope no one sends me any amazing video data tomorrow, so I can have a day off. But really, there is a big blue ocean of opportunity, both in the Vega experiments and in the Ultra experiments. And one person on his first video, thank you, Peter, showed that he could replicate the hydrodynamic stuff that we're seeing in the electromagnetic Magneto hydrodynamic stuff, and so it's about increasing the resolution time and also the frames, so that we can join frames together so we can see perfect animations of the moving of these things. So Peter, I hope you can bring it up to scale. I might give it a shot later in the week, so I've got some various equipment that I can bring to bear. So thank you very much, and I will see you in the next stream.